Hello, and welcome to today's demo from Introspect Technology. Today, we'll be demonstrating several of the capabilities of the SV5C embedded DisplayPort generator. This generator is a self-contained, high-performance test instrument capable of generating traffic for DisplayPort applications running at up to 8.1 gigabits per second. It is operated from the award-winning, Python-based Introspect ESP software environment, which allows a user to get started with DisplayPort testing in a matter of minutes. To introduce the product, here's a quick overview of the key features of the SV5C embedded DisplayPort generator that we'll be looking at today. As you can see the key features on the right, the generator supports embedded DisplayPort and DisplayPort each up to version 1.4. Lane counts can be configured from 1 to 4 per port and includes the auxiliary channel. Full video frame generation is also possible with 8 GB of pattern memory available. The SV5C also provides unique analog controls and signal impairments for stressing a DisplayPort sync device, including per lane voltage amplitude and common mode voltage control, as well as jitter injection, sinusoidal voltage noise injection, and per wire timing skew. In the first half of today's demo, the SV5C DisplayPort generator will be connected directly to the Introspect SV5C DisplayPort analyzer, as shown on the top. The goal here is to show how easy it is to configure the generator and to demonstrate the analyzer and viewer tools. In the second half of today's demo, the SV5C DisplayPort generator will be connected directly to a scope, as shown on the bottom. This will provide a visualization of several of the generator analog controls and signal impairment capabilities. We'll now switch to the software view. Now, if you're familiar with the Introspect software, then you'll be familiar with the appearance and organization of the interface. You'll see 3 sections shown. At the bottom, there's a test procedure window, which is where you would write your Python-based test script. In this case, the script is only 1 line long. It's simply sending a command to configure DisplayPort generator with parameters as will be shown. In the top left, you'll see the components window, which includes the DisplayPort generator component. This component has several properties as shown in the section on the top right. We can configure the number of lanes, the data rate, and patterns to use in our testing. More on patterns in a moment. What you also see in this component is a subset of the various DisplayPort modes that the software can set, including framing and scrambling. You also see analog signal controls and signal impairments. These include voltage swing, preemphasis, and jitter injection. Now on the subject of patterns, we can select several options for pattern types, such as color bars, images, or pattern sequences. Each of these pattern options is encapsulated in a component of its own with an entry in the component window on the left. So let's take a closer look at a color bar pattern that we'll be using here. We can select images widths and heights. We can select from a long list of common image formats and also control parameters such as transfer sizes, symbol stuffing. For example, here we're setting the number of stuffing symbols to 4, and we can also set various mainstream attributes. So let's start the generator and take a look at the received signal, which we can view with the Introspect SV5C DisplayPort analyzer. We've now captured several packets from the generator, and we can look at the results in the viewer. In this viewer, there's a Frames tab, which provides statistics on frames received, and we can look at the images themselves. There's a Burst tab, which shows all bursts recorded, and there's also a Packets tab, which also provides timestamps, classification, and access to data for each packet received. Hyperlinks provide easy navigation between the tabs. Now let's click on a link for the start of a frame, and let's take a quick look at the packets recorded by the analyzer. The top half of the packet viewer shows the table view for packets received, and the bottom half of the viewer shows the captured stream with decoded symbols. The SV5C generator is generating the color bar with all the expected DisplayPort formatting, including blanking starts and blanking ends, and fill starts and fill ends for symbols long as has been specified previously. You can see that the analyzer is also detecting that the generator is sending secondary packets such as mainstream attributes. You can see that the secondary packet has start symbols, and if we scroll to the end, you'll see that there are secondary packet end symbols as well. The viewer is also capable of filtering by packet type, so for example, in this instance, set it to mainstream attributes, And also, you can detect transmission errors on the received data. In the second half of today's demo, the SV5C generator will be connected directly to a scope. This will provide a visualization of several of the generator analog controls and signal impairment capabilities. On the left side of the screen, you'll see that I have the Introspect software open for the DisplayPort generator, and on the right side, I have 3 waveforms already set up on the scope. The first waveform window shows the single-ended output signal from lane 1 of the generator, and you can see that the SV5C generator is already running. The second waveform window shows the differential output signal from lane 2, and the third window shows the eye diagram from the signal on lane 2. You can see that the data rate here is 8.1 gigabits per second, and the UI is 123 picoseconds. In the test procedure window on the left side of the screen, you'll see how easy it is to write a script to modify test parameters. So for example, look at voltage amplitude, common mode voltage, and jitter injection. I can write a simple loop in Python to sweep each of these parameters, amplitude, common mode, and jitter. Note that for common mode, the scope is providing a 50 ohm termination to ground, so the common mode voltage will swing from 0 to 350 millivolts as viewed on the scope. I'll start the loop now. So, this has been a very short demo showing several of the basic capabilities of the SV5C DisplayPort generator. We've seen some of the key DisplayPort generator controls, seen the signal integrity of the SV5C generator output, and most importantly, you can see how easy it is to use the Introspect ASP software tools and set up the test signals that you require. For more information, please consult our website or contact us at info@introspect.ca.